In this video, we're going to look at some standard trigonometric double angle formulae, which are based on the addition formulae or the compound angle formulae, and some new trig identities. So let's start off with an additional formula that you should be familiar with, which says that sine A plus B is sine A cos B plus cos A sine B. And what we're now trying to do is get the identity for sine 2x. So what I'm going to do is replace A and B with x. So I'm going to say let A equal B, which is x. So it's going to be sine x plus x, and that's going to be sine x cos x, and then here we're going to do cos x sine x. Then what we can say from here is that sine 2x is the same as 2 lots of sine x cos x, and that's the first double angle formula for sine 2x. Now we're going to move on to cosine A plus B. So we can write the addition formula for cos A plus B. So it's cos A cos B. So if there's a plus here, there must be a minus here. So it's minus sine A sine B. And then what we can do here is say the following. We can say again, let A equals B. So we can say, which is equal to x. So cos x plus x equals cos x minus sine x sine x. So that now turns out to be cos 2x is cos squared x minus sine squared x. And what we can do is replace, that's the first identity, and then we can replace cos squared with 1 minus sine squared x minus sine squared x, and we're going to get 1 minus sine squared x minus sine squared x, which is 1 minus 2 sine squared x, which is the second formula for cos 2x. And then writing the same formula as before, cos 2x is cos squared x minus sine squared x. This time we're going to replace sine squared, so that's going to be cos squared x minus bracket 1 minus cos squared x. And what we get now is that we get cos squared x minus 1 plus cos squared x. So we get 2 lots of cos squared x minus 1, which is cosine 2x. So what we have essentially is, for cosine of 2x, we have 3 double angle formulas. The first is cos 2x is cos squared x minus sine squared x. The second one is cos 2x is 1 minus 2 sine squared x. And third one is what we just wrote above, 2 cos squared x minus 1. So now we're going to do the same thing for tan A plus B. So tan A plus B, so that's going to give me tan A plus tan b all divided by 1 minus tan a tan b. So we can say let a equal b equal x. So now we can say that tan 2x is tan x plus tan x over 1 minus tan x tan x. So if you want me to go back a step, I could write that as x plus x. So therefore, tan 2x is 2 tan x over 1 minus tan squared x. So we also mentioned there's some other identities that we need to be familiar with for trigonometry. So we're going to stick with what we know already in trigonometry, that sine squared x plus cos squared x is identical to 1. Divide this by sine squared x throughout. Now what we're going to get is 1 plus cot squared x is equal to cosec squared x, which is another well-known trig identity that you need to know at A level. So now we're going to use sine squared x plus cos squared x is identical to 1. This time divide by cos squared x throughout. And now we're going to get tan squared x plus 1 is equal to sec squared x. So another well-known identity at A level, sec squared x is 1 plus tan squared x. Is another identity you need to be really familiar with at A level. Now, the final part of this video, which I want to introduce, is something known as the half angle formulae. Now, it's predominantly going to be used throughout integration, when you meet integration. But I think it's a nice formula to introduce, so when you meet it in integration, it won't be anything that's not familiar to you. So, if we start with the identity that cos 2x is the same as 2 cos squared x minus 1. In integration, we're going to learn that we can't integrate cos squared x or sine squared x. And for that, we're going to have to rearrange this identity to get what's known as the half angle formula. So that means we're trying to make cos squared x the subject. So we can say that 2 cos squared x is the same as 1 plus cos 2x. And since we divide it by 2, we're just going to write it like this. That's the same as a half times 1 plus cos 2x. You would use this identity if you were integrating cos squared x dx. So let's do the other one, which is cos 2x is the same as 1 minus 2 sine squared x. So we need to make sine squared x a subject. So that's going to be 2 sine squared x is 1 minus cos 2x and sine squared x is a half times 1 minus cos 2x. So if you were asked to integrate sine squared x dx, then you would use this half angle formula like so.